Hello, ladies and gentlemen. Today we're going to look at trigonometric functions on the unit circle. All right, and we'll start with our examples. Our first example says the point negative 4, 3 lies on the terminal side of an angle theta in standard position. Find the value of the six trigonometric functions of theta. Well, as they say, a picture is worth 1,000 words. So I'm going to sketch a coordinate system. Okay, so there's my y-axis, and here's my x-axis. And please remember that if an angle is in standard form, then the initial side is the positive side of the x-axis. And the terminal side will be wherever it ends up. Well, if it ends up over here at negative 4, 3, which could be that point right there, then that point, or that ray right there, will be the terminal side, and your angle will be that angle right there. Okay, all right, now, what I'm going to do next is I'm going to drop a perpendicular from that angle, or that point, negative 4, 3, straight down to the x-axis. Okay, while I'm at it, I'm going to go ahead and draw a horizontal segment straight over to the y-axis. All right, and that will kind of help you understand some things. All right, so if I'm looking for the 6 trigonometric functions of theta, what I'm going to actually use is this reference triangle. Let's call that point A. I'm going to use the reference triangle A, B, C. All right. Now, what I'm going to do is this. I'm going to say, okay, all right, if I want, and I'm going to say that this angle in here is the reference angle, if you like. So I'm going to do the sine of theta. Okay. Well, if this point right here, at this point is negative 4, 3, then this segment BC is 4 units long. Okay, this segment over here is 3 units long. And if you remember from your geometry, your Pythagorean triples, that's the old 3, 4, 5 Pythagorean triple. If you don't remember that, you're going to have to do your Pythagorean theorem work and do a squared plus b squared equals c squared. All right, and now if I want the sine of theta, all right, what I can do is I can use this angle right here. I'll just use that angle as my reference angle. I want the sine of that angle. Well, the sine is the opposite, which is 3, divided by the hypotenuse, which is 5. All right, so there's my sine. I then want my cosine next. So the cosine of theta is the adjacent leg. Well, the adjacent leg is the 4 divided by the hypotenuse, which is 5. All right, and then I want my tangent of theta, which is the opposite leg, 3, divided by the adjacent leg, 4. And once you get your 3 basic trigonometric functions, those reciprocals are easy. The reciprocal of the sine is the cosecant, all right, and the reciprocal of 3/5 is 5/3. The reciprocal of the cosine, is the secant, and the reciprocal of 4/3 is 5/4. And the reciprocal of the tangent is the cotangent, all right, and the reciprocal of 3/4 is 4/3. Now, the only thing you got to understand, though, is that these are coordinates on a unit. This point is coordinates. This sine is the y-coordinate, all right? And what we need to realize is that's positive over in the second quadrant, so that's positive. Now, this cosine is actually negative, all right? So that's why it's really, instead of 4/5, it's negative 4/5, all right? And the tangent is this number 3/5 divided by this number negative 4/5. And by the way, you would end up with this, except for a positive divided by a negative is a negative. So the tangent of theta would be negative 3/4. All right, the cosecant is the reciprocal of this sine, and when you reciprocate a positive, you get a positive. And when you reciprocate a negative, you get a negative, so that would be negative 5/4. And then when you reciprocate negative 3/4, that would give you a negative, which would be negative 4/3. Okay, all right, so there are all 6 trigonometric functions of that theta. Now notice that I used a reference angle, and we didn't really talk about reference angles. So we got to come up with some rules for reference angles. And here they are. if theta is an angle in standard position, all right, its reference angle, theta prime, is the angle formed by the terminal side of theta and the x-axis, okay? And the reference angle theta prime for any theta falls between 0 and 360, all right, if it's in degrees, or 0 and 2 pi if it's in radians. All right, and if your terminal side is in quadrant 1, then theta prime is, or your reference angle is theta. They're equal, okay? If it's in the second quadrant, all right, then theta prime is 180 minus theta if it's in degrees, or pi minus theta if it's in radians. All right, if your terminal side is in the third quadrant, okay, quadrant 3, then theta prime, your reference angle, will be theta minus 180 if it's in degrees. It will be theta minus pi if it's in radians. If your terminal side is in the fourth quadrant, okay, and then your reference angle, theta prime, will be 360 minus theta if it's in degrees, or 2 pi minus theta if it's in radians. Okay, so there's your rules. All right, let's turn the page. And we're going to sketch each angle, then we're going to find the reference angle. Okay, all right, so we're going to sketch, first of all, this angle, 3/4 of pi. Well, from here to there's pi. If you separate that into 4 congruent parts, all right, 3/4 of pi would be that angle right there. That angle is 3 pi over 4. That's theta, okay? I'm going to put equals theta. Now, if we want theta prime, all right, theta prime, that's in the second quadrant. And if you recall those rules, I'm going to pull those rules back over here for you, okay? In the second quadrant, to find theta prime, you would take, that's in radians, so we're going to do pi minus theta, all right? Well, we're going to do pi minus theta, which is 3/4 of pi, all right? So that's really 4/4 of pi, if you like, right there, 1 whole pi, minus 3/4 of pi, which gives you pi over 4. So theta prime would be 1/4 of pi. That's this angle right here, which is the one I used a moment ago when we did problem number 1, okay? But it wasn't pi over 4, it was a different angle measure, okay? All right, let's go to B. All right, in B, I'm going to graph, first of all right, I'm going to graph the angle -150. So negative means we're going to go in a clockwise fashion, not 90, but 60 more degrees. That would be over here. So that angle right there is theta. That's equal to -150 degrees. There's the graph of that angle, a sketch of it. Okay, all right. Now, what we're going to do next is this. That angle is coterminal with this angle over here, all right? And that's the one really I'm going to use when I go and use my rules. My rules say that if it's in the third quadrant, that theta prime would be equal to theta minus pi. Well, theta has to be positive because it tells you over here that for theta, any theta, if theta is between 0 and 360, well, -150 is not between 0 and 360, okay? So we're going to find the coterminal angle by adding 360 to that. Let's just take and add 360 to that so that we can get this angle over here, so that theta's positive. And when we do that, okay, it takes 50 to get to 200. 160 plus 50 is what? What is 160 plus 50? 210. So this is the same thing as a 210, which is 80 plus 30 more, 210 degrees, okay? So we would do theta, which is 210 degrees, all right, minus, not pi, we're doing, this would be, theta minus 180, excuse me. Theta minus 180, where theta is 210, minus 180, which will be that 30-degree angle that we have right there. Okay, and really, technically speaking, it's what you can do is just use your terminal side and either the negative side of the x-axis. You want your reference angle to be an acute angle. Or if it's over here in one of these two quadrants, you'd use the terminal side and the positive side of the x-axis. Okay, so that's one way you can do it, or you can use the rules, whatever works best for you. Okay, all right, let's graph pi over 6. Here's theta being pi over 6. All right, that is in the first quadrant. Well, in the first quadrant, the reference angle, if you use the rule, all right, the reference angle is theta, provided, of course, that theta is positive and between 0 and 2 pi, which it is, okay? So theta prime is theta, which means theta prime is pi over 6, okay? All right, let's go to negative 60 degrees. Okay, so here's the initial side, all right, the positive side of the x-axis, okay? And we're going to go clockwise because it's negative 60 degrees. So that would come down here. There is negative 60 degrees. Now that's theta, but remember, we want theta to be positive, all right? So what we want to do is come the other way with that, okay? That's not 90, 180, 270, but 30 more than 270, which would be 300 degrees, okay? So that same angle, theta, is 300 degrees, and that is between 0 and 360, and that means we're going to use our rule, all right? That's in the fourth quadrant, and it's in degrees. So the rule says that the reference angle, theta prime, is equal to 360 minus theta. And we want to use this theta. These thetas are equivalent, by the way, but we want to use the positive one because it's between 0 and 360. So theta prime would be 360 minus theta, which is just 60 degrees. There's your reference angle right there, okay? And by the way, it's just that angle right there. It is 60 degrees, but you just basically just got to use your rule and figure that one out. Okay, all right, let's go to example number 3. Example 3 says, let the secant of theta be equal to the square root of 29 divided by 5, where the sine of theta is positive. Find the exact values of the remaining 5 trigonometric functions of theta. Okay, well, recall that the secant, all right, is the reciprocal of the cosine, okay? So by the way, you can immediately reciprocate this, and which would give you the cosine, okay? All right, so the cosine, immediately we know the cosine of theta is 5 divided by the square root of 29, all right? Now, you can't leave a radical in any denominator, so you're going to multiply both of those by the square root of 29 to rationalize that denominator. So your numerator would be 5 times the square root of 29 divided by 29. Okay, all right, now I am going to tell you that if that cosine is positive, the cosine is positive in the first, that's an x-coordinate, your x-coordinates are positive in the first and the fourth quadrant. So with this information, just this part right here, the secant being positive, I'm either in the first quadrant or in the second quadrant. Excuse me, fourth. First or fourth, that's where the x-coordinates are positive. Okay. Now, this one tells us the x-coordinate is, the y-coordinate is positive, which means we are in the first quadrant. So I'm going to sketch this angle over to the first quadrant, somewhere over here, okay? All right, and then I'm going to say, okay, I'm going to put a point here, and I'm going to drop that down to get myself a right triangle, all right? And then I'm going to let that be my reference angle, theta, okay? And I know that the cosine is the adjacent leg, 5, divided by the square root, the hypotenuse, which is the square root of 29. Okay, and now I am going to use my Pythagorean theorem and find the opposite leg length so that I can find all the other trigonometric functions of theta. Okay, so a squared plus 5 squared would have to equal the square root of 29 squared, which means a squared plus 25 would have to equal 29. Subtract 25 from both sides, a squared would have to be equal to 4. Take the square root of each side, a would be plus or minus 2, but since we're talking about a leg length, we're going to use positive 2. Okay, all right, so over here is 2 units. And now if I want the sine of theta, which I do, the sine of theta is the opposite leg 2 divided by the adjacent leg, by the hypotenuse, which is the square root of 29. Now, do not leave a radical in a denominator, so we would multiply each of these by the square root of 29. That would give me 2 times the square root of 29 divided by 29. So there's your sign, okay? All right, now I want the tangent. I want the tangent of theta. Well, the tangent is the opposite leg length 2 divided by the adjacent leg length 5. And now once I get those 3 basic trigonometric functions, the reciprocal functions are just reciprocals, all right? Now, I don't need the reciprocal of the cosine because that's sitting up here, all right? I do need the reciprocal of the sine. The reciprocal of the sine is the cosecant of theta, and I can reciprocate either this value or that one. It really doesn't matter. However, I don't want a radical in the denominator, which means really, if I'm going to reciprocate it, I don't want one with the numerator, which means I'm going to use this one right here and reciprocate it. When I do, the square root of 29 goes to the numerator, and positive 2 goes to the denominator. Okay. All right, and now I'm going to reciprocate the tangent. Reciprocal of the tangent is the cotangent. And when I reciprocate 2/5, that's going to be equal to 5/2. And there are all 4, and I'm going to values that you were looking for, that are actually all 5 other trigonometric functions of theta. All right, let's go down to example number 4. Example number 4 says, a student programmed a 10-inch robotic arm to pick up an object at point C, okay, and rotate through an angle of 150 degrees in order to release it into a container at point D. Find the position of the object at point D relative to the pivot point O, okay? Well, when they say pivot point, that's I'm going to make that my the axis of my coordinate system. All right, because I'm going to make a coordinate system. So there's my y, and here's my x-axis. Okay. All right, and you can put the ray there if you want. All right. So what I'm looking for is this point over here. Okay. I want the position, and every position on a coordinate plane has to have an x-coordinate and a y-coordinate. All right. Okay. Well, what I'm going to do is drop a perpendicular to the x-axis to create that triangle DGO, if you like, which will give you that theta prime, your reference angle. And that would be 180 minus theta, so here's theta, all right, and that would give you a 30-degree angle, okay? All right, it's the supplement of a 150, by the way. So that's a 30-degree angle. All right, and what I need to know is, I know the hypotenuse is 10 units long, right? Okay, well, if you recall from your geometry, if you have a 30-60 right triangle, all right, the short leg is opposite the 30, and it will be half the length of that hypotenuse. Half of 10 is 5. And the long leg would be the short leg times the square root of 3. All right, so OG would be 5 times the square root of 3. Okay, so now I want the coordinates of this point. Well, the coordinates of this point has a negative x-coordinate, and that's this value right here, negative 5 times the square root of 3, and a positive y-coordinate, which is positive 5. All right, and we've got everything we need now. The location of that point is, the negative means to the left, okay? So, or if you want, let's just write it this way. The exact coordinates of point D is negative 5 times the square root of 3, 5, all right? Provided, of course, that we put the pivot point at O, provided the pivot point is the origin of the coordinate system. of the coordinate system. Oh, I need the word system, I'm sorry. Okay, and now if you wanted to say anything else, you could say that it's, if you did this right here, this would be negative, if you approximated, it'd be negative 8.66 inches left. So that's what you would do. It would take this point that you pick up out here and move it 8.66 units left and 5 units up. That's what would happen. So you could say the object is 8.66, and what were these units? Inches, okay? Inches left and 5 units up, 5 inches, excuse me, inches up from the original point, or from the pivot point, excuse me. Okay, 8.66 units left and 5 units up from the pivot point. And I think we've pretty well established what's happened with this robotic arm and the object that it picked up. All right, if you have questions, please call me, show up in a Google Meet, email me, whatever you got to do. Have a good day. Bye.